All right, welcome Web 19. We're going to be talking about JavaScript Module 2 and specifically closures, callback functions, and advanced array methods. These are all derived from yesterday's learning with objects and functions. So we're just going to push forward on what we've been doing here. So much so, let's just dive into it. We've got a lot to cover today. But if you recall, yesterday, we started with a block of code, right? And we learned that this block of code protects us from the outside. So going back to our funny analogy, which I still think is valuable, which is like the world is the global scope. So the global scope, the world in which our code lives in. And then we have our own little kingdom, right? We talked about this yesterday. Kingdom of code. And so this kingdom of code has its own set of rules, its own abilities. That set of rules we call scope. So scope is between these two curly braces. There's also scope out here. It's just like in the world we live in today. We all live on Earth. We are all Earthlings. However, we do have places and territories and states and cities and towns that we live in and different influences there. Let's see. Oh, yeah. Forgot to open up that questions thread. So Lena opened up one. I'm going to say that's the official one. So thank you for opening that up. It's been pinned. So go use that for your Q&A thread with the fast reaction of our awesome project managers. Okay, so taking this kingdom of code example further, we're going to get into our first concept today, which is a closure. So before I jump way into this, I want to step out to Legos. I love Legos. They were, Mega Blocks are okay, I guess, but Legos were like the big thing. And you can see they've got these little pips on them, right? And anybody that's stepped on a Lego has felt those, right? It doesn't feel good. But at the same time, you know how to put these things together, right? So what if a kid was like, why do those things stick together? Well, you would say, well, the matching pips line up with the indentation on the bottom of the Lego. And the kid would look at you like, what the freak did you just say? And they'd say, what's a pip? Yeah. Or they'd say, well, what do you mean indentation? And then let's say you could actually describe the pip and the indentation perfectly. And they'd say, that still doesn't make sense. Why is it doing that? How does it stick? Well, physics. What? Physics? What do you mean physics? Well, there's a pressure differential, and the pressure between them is equivalent, so they stick together. What? So this kind of thing is going to happen today with closures. Closures represent that pressure between the two Legos and allowing us to stick them together. So I want you to think about each Lego block here being a function. So this is a function, this is a function. We're going to be able to stick functions together. They're going to be able to meld together in a certain way. And that melding is called a closure. Okay? I'm going to describe some of the pips and pressure problems that we can solve with JavaScript. But I want you to understand that you don't need to know this information to put two Legos together, right? Like you could just slap them together and start building something. I would bet if we took a senior developer off the street, off the street meaning out of their job, and just said, hey, can we take 10 minutes of your time? Sure. Where do you work? I work at Facebook. Wow, you're a really good developer. Sure. Okay. Could you explain to us what a closure is? And I bet you they'd crap their pants. They wouldn't know what to say because it's not something you need to identify and verbalize every day of your life as a developer. However, if I were to quickly explain a closure to that developer, they'd go, oh yeah, I use them every day. I just don't actively write them. I don't actively say, I'm going to write a closure today. It's the same concept here with the Legos. When you're building Legos, you don't go pressure differential, pip. You know, you don't do that. You're like putting Legos together and building something. So that's where I want to start with today, is to say, look, I'm going to show you some stuff that you will be using, but you don't need to be like expert at being able to explain this to everybody on the street. All right. So that being said, let's talk about how we can put two Legos together and how this can work. Number one, we've got to have a Lego. And in our case, we're going to be building a function. So here we go, function. And remember, we called it kingdom. Let's just keep going with this. I really like this. So kingdom, excuse me. By the way, what kind of function is this, just by the nature of the syntax? It's a function, what? Declaration, very good. What makes it a function declaration? What are some attributes of a function declaration that we're seeing here? That's right, it's named, it's not assigned. Very good. Very good way to put things. A function expression, by the way, would be assigned to a variable, right? And usually anonymous function or an arrow function. So good job. All right, so how do we invoke kingdom? How do we even get kingdom to work? Because right now, it's just sitting in the global scope, not doing anything. It doesn't work. So if I tried to hit settings, by the way, and get my run button back in here, let me console log really quick. Okay. So if I hit run, nothing, right? And that's because kingdom is being guarded by the function name. Nothing's allowing this to run. This block of code is being protected by this definition and declaration. Okay, good. I'm seeing all the answers, which are the invocation, right? The magic spell, if you will, of invoking out of our spell book our kingdom. So we say, kingdom, I invoke thee. Well, that is not how you invoke. There we go. So in this case, if I hit save and run, there's our string hello. So what we've done here is we have invoked our function declaration using a console log out here on our console. All right, this is all review, hopefully. Like, we beat this horse many times yesterday and in pre-course work. We just have definitions to talk about them now. So this is our Lego. This is our red Lego right here. Now let's go look at how we can make a blue Lego. Notice the red Lego's on top. It's the topmost Lego. And all these other Legos are basically nested inside of our red Lego because the blue Lego can't move, right? The red Lego is on top. It's stuck. It's nested, just like we did with HTML. So similar in HTML, if we do something like this, we've got nesting going on, right? This is not a new concept. Like, this is like, yeah, we've been doing this for weeks. Well, guess what? In JavaScript, we can do the same thing. We can nest other pieces, other syntax pieces inside of other syntax pieces. So what I'm going to do now is I'm going to nest a city inside of our kingdom. So the kingdom's huge. We've got multiple cities. Let's make a city. So function, city. The same thing, right? I have my kingdom invocation. So let's go in here. We'll say, I am in the kingdom. And then here, we'll just borrow this and say, I am in the city. Right? Okay. Now, this is a little trickier. We haven't talked about this before. If I run kingdom, is I am in the city going to run because it's nested inside of kingdom? What do you think? Negative? Okay, let's try it out. Run. No, there we go. Sweet. That's the desired behavior. No error, by the way. This is error-free code. It's just that we haven't invoked anything. So, yes, we could invoke it right here, but it would cause a little bit of confusion because functions are hoisted, so we could do it. So let's just invoke it down here at the end. So let's put a note here. Say, hey, this is the kingdom. And this is the city. So we've got to invoke city, right? So city, invocation. All right, let's see if this works. Save and run. There it is. Kingdom works. I am a city works. And now we've got two Legos. We've got a red Lego, which is kingdom. We've got a blue Lego, which is our city. Okay. Now let's put another function in here just to show 3 levels deep, just like we can do in HTML. Like we can go n amount of levels, by the way. But there are rules, like try to avoid going even more than 3 deep in JavaScript. It's pretty hefty. So city is probably not a good idea because we already have a city. So what is inside of a city? Well, usually there's a town. So we'll have a town inside of here. We'll console log. I'm in the town. Okay. In this case, we've got town. And of course, I'm just giving myself some white space just for breathing room. We invoke town. All right. Let's see if we can get all 3 consoles to log, or console messages to log. I am in the kingdom, I am in the city, I am in the town. Excellent. We now basically have gone through red, blue, and let's say green, just in this example. So these are all interconnected by nature of the nesting that we've done. Okay, nothing here should be weird. Like I'm not setting you up for disaster here. I'm just showing you this is exactly how nesting works with functions. Now, before we go even deeper than this, you might be thinking, what is the value of a nested function? That value will continue to reveal itself as you program longer. It's hard to describe the value to you without having had experience with it. But I can tell you this, the value of having nested functions allows you to protect your code from other code. So it's just like, yeah, it's just like the same value as Sass and less. Melissa, very good bridge there. Where we have mix-ins, right? Or we have code that we want to use later. Nested functions are great because they protect certain pieces of code from executing on accident, right? Imagine a world where everything you wrote in your program executed no matter what. Like you couldn't prevent it from executing. We'd be so limited in our ability, right? Every page would have to be one single thing that it could do. Oh, it'd be awful, right? Think about a login system, for example, or signing up for anything. If we can't hold on to things and execute them later, it'd be awful. So nested functions allow us to hold on, not run the code until we need it until later. All right, so at this juncture, this is probably just like, cool, I get it, nested functions, moving on. So here's where things get more interesting. So far, this is like cool, but I want to talk about what I did in here. Maybe you didn't notice it. I'm using a new syntax that ESNext. I'm going to say anything ES6 and up is called ESNext. I'm using a special symbol. Maybe you didn't notice it, but it's called a backtick. This is called a string template literal. So if we come in here and you can see I've got a backtick in here. That is not the same thing as a quote. So one side by side, you can see they're totally different, right? Look at your keyboard. You'll see the backtick. If you're using an English language keyboard, I should say, next to the number 1, on the left of the number 1 on your keyboard, you should be seeing a backtick. Go ahead, try it out. You've been using it to write code inside of Slack. Like it's the same thing. So here's the interesting thing. Inside of JavaScript, we used to have to use, and still can use, by the way, the plus sign to combine things together. Also, it can add things together, which is confusing. So the plus sign had been used as a concatenator. That's a fancy word to say bringing things together. So if I brought another string together, like this, I was just like, hello, or test. Let's see what that looks like in our end result. Save and run. And you can see test is concatenated onto the end of my string here. And of course, it does respect white space. So if I wanted a space there, I could hit save and run. And you can see the before and after. Okay? This seems like, yeah, I get it. The problem is, every time you want to put multiple things together, you have to use that stupid plus sign again. So imagine this where if we had to piecemeal this thing together and we had to add more things in. Plus 45 plus another string plus, do you see how awful this can be if we have multiple things? So if we save it and run it, you can see we're getting all these things. Oh, I forgot my white spaces. I got to put them in. Okay, save and run. And now we get whatever we were trying to do. So the cool thing is I can take this exact same string here, same log, I should say. And if I use the string template literals, I don't have to use a plus sign anymore to bring different things together. I can escape them. So I can actually get rid of all this stuff here. Now let's say that 45 and 56 were, inside of some variables. So, const, right? Num, assign the value of 45. Const num2, assign the value of 56. So in our example up here, to get 45 and 56 to go in, I would have to bring in the reference to num like that, right? And then num2, there we go. So this is the equivalent statement. Now I had to do a bunch of concatenation, right? So now if I bring this stuff in, here's how it works in string template literals. It's a new weird syntax, but it's just get used to it. It's a $sign and then 2 curly braces like that are wrapping around the thing that you want to convert. So in this case, it'll be num1. And then use the same syntax for the second thing like this, num2. So look at that. That's clean. So in this case, all the white space is respected. All the interpolation, there's that fancy word again. So it's swapping out the symbols, right, for something else later, 45 and 56. So if I hit save and run, let's see. Oh, I got to have my ending backtick. Must have got deleted along the way. Save and run. And you can see they're identical statements. So this stuff at first is like, okay, that's cool, but I don't think you understand how much I had to do to concatenate all these together. So like plus, quotes, space, space, quote, plus, versus none of that. I just had to do the $sign and curly braces. So multiply this by hundreds of thousands of lines of code, and man, this is so much more consumable and easier to read as a developer. So I just want to talk about, this is how I used to code for years, and then now with these new string template literals, we don't have to worry about that. So I'm going to be using these from now on. And I wanted to give you an introduction to their value. Okay. So that being said, let me get rid of these silly values and go back to our original thing. I just wanted to show those to you and how it's working, because I'm going to be using them for the rest of our time here. Awesome. Thanks for the link in MDN. All right. So at this point, I am the kingdom, I am the city, I am the town. I'm using my string template literal here so I can get my values in easier. So let's say the kingdom has a declaration from the queen. Okay. So let's say that the queen runs the kingdom. So const queen, and we'll assign the value of a random, we'll say Queen Ruby. Sounds like a very queenish name. And so we've got Queen Ruby, and she's going to have a declaration for the kingdom. And the declaration is going to be, long live the queen. So we'll say, long live the, and then we'll say, Queen Ruby. So we can pop this in. Oops, got to use that $sign, not an ampersand. Let's see if this thing works. Run. Long live, let's get rid of the, make more sense. So long live Queen Ruby. Okay. So here's the thing. in this feudal kingdom, I guess we're going to get a little bit more medieval here. In our cities and towns, before anything is declared, everybody must say, "Long live Queen Ruby." Otherwise, off with your head. So in this case, I've got to make sure this statement can be read in every city and town throughout the kingdom because it's required by law. So I'm going to come over here and I'm going to say, the city says, so we know where we are. So right here, this is where things start to get interesting. Everything else up until this point has just been syntax review, maybe a little bit extra with the string templates. But here's where things get new. So right here with the queen, do you think this is going to run? Notice that I did not pass queen as a parameter, as an argument, or receive it as a parameter. There's no queen right here. Nothing, right? So is this going to work? Moses says, yes, closure. I like it. I like the straightforward nature of your comment there. Everybody else is saying yes. So here we go. Save and run. Aha, it worked. So the top level function, the top Lego, the red one here, long live Queen Ruby. Then the city says, long live Queen Ruby. They're following the law, right? So in this case, it's working. So here's the interesting thing. Queen is nowhere to be found. Where is Queen? This is where it's interesting. Like some languages can't do this, by the way. JavaScript has this built into it as a feature. Other languages would actually throw an error right here because they would say, Queen is not found. But because of the two-pass compiler, there's that compiler thing again. There's something interesting going on. So let's review the compilation. So remember in the first pass, what does it look for? What's the key word? Starts with an R. The references, that's right. So let's identify all the references we need in the first pass. So how do functions work? Well, first off, it has to define all the function declarations. So it goes into the nesting and says, okay, town, city, kingdom. Okay, cool, I've got my references. And then it goes into the functions and says, okay, what are my references I need here? Okay, queen, because remember, this is not a value, that's a reference. And then it comes down here and goes, huh, here's a reference. But this is the interesting part. Here's where the closures reveal themselves. So queen is saying, I don't see it. Where's the queen? Do you have it, city? And city says, nope, go fish. So then city goes up to kingdom and says, do you have queen? And in fact, we do. It says, yeah, I've got it right here. You can use it when you need it. The you can use it when you need it, that's a closure. So in this case, this question right here comes back, and we've just identified our first concept of what a closure is. It's code that's been identified elsewhere that we can use for later. So in this case, the function says, here's your closure. I'm going to give it back to you. You need it on the second pass. So first pass is done. Second pass goes through. And let's identify our references. So we'll use a different color here. So on our second pass, we find Queen Ruby is actually the string value that we need. And then it pops it into all the other references. So Queen Ruby, check. Queen Ruby, check. So the second pass fills them in, and then our invocation occurs. And then the code executes, boom, 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 and then we get all the information over here. So all this stuff came from the original function. Pretty cool. Okay, so let's review what just happened. Queen was set up inside of kingdom. It was originated from, was born into the kingdom's scope, right? That concept of being born into something or the original place where it was called, That's called lexical scope. The lexical scope of queen is kingdom, because that's where it was initially defined. So lexical scope is all about the original of where it was defined. So in this case, Queen Ruby's lexical scope belongs to kingdom, because that's exactly the first time it was mentioned in our whole narrative here. So queen belongs to kingdom. That belonging, I want you to think about belong and lexical as being pretty much synonymous. So belong and lexical. So when people start talking about lexical scope and you read those Medium articles and you want to bash your head against the wall, step back away and think, oh, lexical is all about belonging to somewhere. You know, when someone says, where are you from? They're basically saying, what is your lexical scope? And you say, well, my lexical scope is Utah. And you might have a different lexical scope. So in this case, where do you belong? Where did you come from? And so in this case, queen belongs to kingdom. Therefore, queen is bound to the kingdom's lexical scope. Okay. Lexical scope is extremely important when it comes to closures, because that original belonging gives you a home base, so everybody else can know where you came from. All right, so let's take this even further down to town. Go down to town, pop this in. The town says, long live Queen Ruby. So let's save and run. In this case, we now have long live Queen Ruby in the kingdom. The city says it, and the town says it. So interesting thing here, in your opinion, based on what I just talked about, is queen getting its reference data from city or from kingdom? Which one? Remember, lexical scoping. Okay, good. I'm seeing some of you say city, but I want to say, I know what you're thinking. You're thinking, well, city came from, towns nested in city. But remember what I talked about, the lexical scope, where it came from originally, and that is kingdom. Pretty cool, right? All right, so a lot of this stuff is great, except we can't see the word closure anywhere. Well, guess what? We actually can if we use our debugger statements. So you're going, what? Well, check this out. Debugger is a special JavaScript statement that only enables when you're using your inspection tool, like when you're using your dev tools in your browser. So I'm going to go ahead and put debugger statements at the end of each of our logs to see what happens. Now I'm going to inspect, open up the sources tab here, just like we did yesterday at the end of our guided project, and we can see all of our code. But watch this. When I hit run, we're going to see everything come alive, and the debugger is going to stop on line 8. Here we go. Run. Everything came alive, and look what happened over here. This is kind of like how Quokka works if you've got a Quokka, if you used Quokka yesterday. You can see that the value Queen Ruby has been assigned, and you can actually look inside of here, and you can see our scope. This is pretty cool. So we can actually see all the stuff that we were saying was like kind of an analogy. Well, no, it's real. So in this case, our local scope, meaning the scope in which belongs to the function that we're calling, so kingdom, here's the stuff that resides in kingdom. Well, first off, the city function resides in it, right? Because there's the city. And also there's a this keyword, which we'll talk about tomorrow. So just hold on to that for tomorrow. And then we've got queen. So there's Queen Ruby. And Queen Ruby, notice that there's nothing special here except that it's saying it's a variable value, right? Okay. Nothing cool here. Let's move on to the next function and see what happens. Oh my goodness. There's a closure. So in this case, we can see closure. And notice where it came from. It came from kingdom. Well, what could be inside this closure, I wonder? It's Queen. So this is exactly what the compiler is doing. It's going through, setting up references, and saving things for later. This closure was saved for later and popped inside of our the city says, long live the Queen, right? So this is really interesting. Now, if I hit the next button, you can see the next phase. And you'll notice that we have the same closure from Kingdom, Queen Ruby. So closure is us saving it for later to be used at another time inside of a nested function. So going back here, Queen Ruby was identified in the red block. Both the blue and the green block received Queen Ruby by nature of the pips that are touching, right? And those pips are the closures. So in this case, we've now identified what a closure is. It's related to the lexical scope of the original function, right? The place it was born, and then passed through by reference when the compiler went through. All right, let's prove this even further by adding another item. So this is great because it showed us from Kingdom, what if City had something that it wanted to pass on? What if the mayor got a little power hungry and was like, I want people to say long live the mayor in the town. So the mayor comes in here, and the mayor is Jim Bob. So in this case, Jim Bob says, anybody in the town, you've also got to say, long live Jim Bob, the mayor. Jim Bob's got some power issues. So now what's going to happen is we're going to go into our inspector tool. We're going to hit run, so it triggers the source. So notice Jim Bob is not visible up, right? Like Jim Bob is not available in the local scope here. So I want to point out something. This all goes down. We can't actually push things up. It's against the laws of how the nesting works. It's the same kind of concept with like an H1 couldn't impact a header tag, for example. It doesn't work that way. Everything is about cascading down. Same thing in JavaScript. And same thing with in life, right? Like you can't change your parents' attributes by changing your attributes. It doesn't work. Okay. So in this case, we've proven something interesting. You can't go up, you can only go down. Next step. So notice Jim Bob is inside of local, right? He's not inside of closure. I want you to be very clear about this. The closure came from Kingdom, right? So in the case of City, Jim Bob is only on the local scope, meaning it only belongs to that. But here we go. Here's the next step inside of town. So we're going to jump inside of here, right? Click, and look at this. We have two closures now. One closure points to City, because that's where Jim Bob came from. One other points to Queen Ruby, because it came from. So what are these things in parentheses? What would you describe these things to me? These are the what? The lexical scope. Yes. Very good. Because why? Why are they called lexical scope? It's where they came from. Yes, and yes, exactly. Perfect, Kimberly. Jeremy, initial, yes. Very good. All of you are getting that. So this is closures, my friends. It's all about lexical scope, like where you came from and how are you used later. And that's it. So conceptually, you've now accomplished what a lot of developers don't even understand, and that is closures. So why does this help you? Why did we spend all this time to talk about these things? Well, I honestly believe that these kinds of concepts will push you from a beginning developer to a mid-level to senior developer faster because there's less magic under the hood. The fact that we can remove magic and say, no, the compiler is actually setting up references to the lexical scope and using them later makes you so much better as a developer when you're making decisions. Even though some people can make amazing Lego structures, maybe they don't know why they can stick together. So these kinds of things are just going to round out your education and help you understand JavaScript at another level. Okay, let's take a 5-minute break. When we come back, I'll answer any questions. 5 minutes. All right, time is up. I'm going to open up the questions here. Why are the outputs showing up in reverse order? So let's go look at our JavaScript here and clear this, save it, and run it so we get everything in order here. Okay, so long live the Queen Ruby happens first. So I actually think this is in order. Maybe it was just confusing with all the other links in here, but it hits this first. City says long live Queen Ruby, etc. One really cool thing that would be, I think, great for all of us to see is a program called Python Tutor. And you can actually change it to JavaScript, pop in your code, and visualize the execution of said code. And so you can see here the 15 steps of how the compiler understands and reads this code. So if we step through the code here, forward, you can see, remember, the green line is the code that was just executed. So Kingdom is executed. The red line is where it's going next. So don't get confused. It's a big thing I think sometimes people get confused about. So Kingdom executes. Then it goes find our const queen, looks up our console log, goes to the debugger statement, jumps down to city, sets up the const mayor, looks at our console log, looks at the debugger, jumps down to town, looks at our console log, looks at our console log. But I want you to notice what's happening while I'm doing these things. So you can see over here where Queen is getting filled in, and Queen is getting filled in, and Jim Bob is getting filled in. And you can see this stuff in blue right here. These are the things that it's saving for later. These are our closures. Okay? So then we step forward and step forward. Okay. So now we're at the end of our debugger statement, and then we come back out. So then the code is executed, code is executed, code is executed, and then we get our output final. Pretty cool. You can do this with any valid JavaScript. So this is a great way to really sit down and realize what every line is doing that the compiler understands. Pretty cool. So let me give you a link there. Okay. So yeah, that's an amazing thing here. Is there a good reference? There you go. The reference I just gave you. Beyond that, I would say you don't know JavaScript. So you don't know JavaScript. Oh man, this is something I give you with, like, maybe read this later in life, not right this second. But if you want to really understand what's going on with the compiler and to pass and all that stuff, it's all here, right here in scopes and closures to be specific. It's free, by the way, but of course you can pay for that to support Kyle Simpson, which I totally have done and recommend to you. Kyle's an amazing author and JavaScript thought leader. Doesn't mean he's right about everything, but definitely means he's got some great material for us. So if you want to read through all this stuff, you can, but not right now. Not right now, please. Okay, so if you tried to do a const queen in a nested function, will it allow you to redeclare the value? If you were trying to come back into the scope and say new queen, so then in that case, the local scoping, so let's go try it out. So the question says, hey, could you come down here and say const queen and rewrite this to say, you know, Queen Jim Bob? We'll come in here and we run this code. So save and run. And notice what happens. Why does this happen though? So Queen Ruby just got ousted. That's because the lexical scope changed, right? The origination here inside of these curly braces overwrote the original queen. So we do have to be careful to not overwrite the original. Great question. Great question, and it's because of the local scope, so be careful about that. How do closures get their name? I'm not really seeing any way in which closures stop or close anything. So closure is all about being enclosed. So that's where they get their name. It's all about the enclosing nature of the nested function. So from this curly brace to this curly brace is technically enclosed everything. So that's where we get it from. It's all about the nesting natures. So kingdom is the lexical scope, Queen Ruby value, yes. And the closure is the invisible glue that makes Queen Ruby the value pass other references. Yeah, that's a great way of thinking about it, invisible glue. So a closure is a lexical scope of the function that has the reference, or the lexical scope of the reference. So a closure is the lexical, it's referencing the lexical scope of the function. Yes, so this one is right. If I say Python also has closures, is that sentence true enough for today? Yes. So I'm not coming from a Python background, but a lot of modern languages do have closures built into them. But they are slightly different in their execution with syntax because JavaScript has its own unique compiler, right? Versus Python, versus Java, versus whatever. So be careful. The concept of a closure does persist, but the execution can change. So just focus on JavaScript closures in this case. Would you recommend composition over inheritance? Yes. So basically, inside of those nested functions, it looks for the reference of queen until it finds it. Yes. And if it doesn't find it, it throws a reference error. So if we tried to set up a reference that didn't exist, we would get an error saying, queen not found, if it wasn't in the lexical scope. So good observation. The compiler goes 2 times before the invocation occurs. So the compiler runs through every reference 1 time and then passes in the reference, and then the invocation occurs. So yes, references and values are set up, and then execution occurs, as we just saw here. What is my opinion of Eloquent JavaScript book? Probably one of the best books right now in industry. If you didn't call on queen in city, would it still show up as a closure? No, it would not. Let's try it out. I think that's a great question. So for example, if I don't have it here and I don't have it here, and I don't reference queen anymore, and I do a console log of like here where it's like long live, the mayor. So Jim Bob is just totally broken the law here. So if we were to look at our code here, hit run. If your name's Jim Bob, I'm not trying to offend you. It's just a good name. All right, so if we hit the next button, notice there is no closure. So closures are only used if data needs to persist through the nested functions. So in this case, mayor shows up as local scope, but queen is no longer anywhere to be found, right? And that is because queen is no longer being used. So it's not in a closure. That's the beauty of the compiler mentality, is it always tries to find queen first. And if it does, it stores it for later when the invocation occurs down here. Great question. I think magic makes things a lot harder to understand. When we get to React, we'll be using Create React App. We're going through it to understand what it does. A little bit of both, but once you understand what it does, you never want to set it up manually again. So you'll get a little bit of both, but Create React App is a great tool to get things up and running. Really, a lot of the magic removal is happening right now with fundamentals. Okay, we got to move on to the next thing. Let's see, we've got a couple. I've got the link out to you. What's the difference between local scope and lexical? I think the best way to describe it is lexical scope can persist, whereas local scope dies the second it moves on. So local scope dies after the next function, like it literally dies. No longer exists. So as soon as this function gets done, like if we go back to the Python tutor and we go back in steps here, as soon as we get out of like the function city, the local scope here actually dies. It stops having impact. Whereas a closure will continue to live on into the next thing. So that's the difference between local and lexical. One dies, one goes on. Saved for later, right? Can a function be a closure? No, you need a nested function. It still works if the variable is outside of the outer function. Does it mean that there's a global closure? So global is different than closures. Global is global. So if it's global, you can reference it multiple levels deep. It's worse as far as like passing data. So again, you can see why it's so dangerous to have global variables, because anything can access it. Closures just seem like simplified classes and objects. Is this a decent thought process? No. Closures are the tool in passing data between functions. They're not classes and objects, so don't get those mixed up. Think more of closures are lexical scoping, passing data for later. Classes and objects are much more complex. Okay, those are really good questions. Let's move on to the next concept. So in this concept, we've gone from kind of glue and Lego bricks kingdom. We're going to go now into more practical things. So we had to go like deep dive on some big concepts, and now the rest of today is going to be actual use cases of functions and what we can do. So I want you to kind of put to bed closures, like put it to bed for a little bit. Let's just clean it out of our systems and focus on this new concept. So this new concept is called higher order functions and callbacks. Okay? Probably do this. So this sounds pretty crazy, but once we look at it, we'll start to be able to consume it. So I'm going to go ahead and comment this invocation out so we don't accidentally keep getting these strings in here. So a higher order function is the first thing we need to understand. So if you recall yesterday, I said that we would be using functions and we would be passing other functions as parameters. That's exactly what a higher order function can receive. So I'm going to call it what it is, higher order function, just verbatim. Now, does the name matter? Does this name matter? Or am I just doing this as a teaching tool? Just as a teaching tool. The name does not matter. I could call this Jim Bob, and it would be just fine. But I want to call it what it is just so we can kind of wrap our minds around it. Yes, Kimberly says something very good. It matters for future developers in real life. So you want to make sure your function is named appropriately for what it's doing. Eric, I'll smack you. Just kidding. Eric said, can I call it foo? So in this case, if I were to invoke this function, I could say higher order function, invoke, right? Nothing's going to happen because I got nothing going on. If I say console, well, let's stop using consoles and use the proper function, which is return. So you're never console logging in a real project except to test. You're always returning something. At least otherwise, why would you have a function if you're not trying to do something? So let's return a string value. I'm going to use my backticks and say, I am in the higher order function. Okay. So in order to get this to invoke, I need to wrap it in console.log, right? That is a better, proper implementation. So if I hit save and run, excuse me, you can see I get the return string, I am in the higher order function. So nothing new here except for the backticks that we introduced just barely. So we also learned that we can pass in arguments. So let's say we wanted to add something together. So we'll say 2 and 4. I can return the values that I find in the parameter, right? So in this case, I could say num1, num2. All right, what are these values called? What are those called? Arguments, very good. What are these called? Parameters, very good. Okay, so if I wanted to add these, I could put it in backticks and escape it, but I don't need to. In this case, we'll say num1 plus num2, right? Because we're going to return the result of 2 plus 4. Gonna hit save, clear this out, and run it. 6. Okay. This is all review from yesterday, but I think after the closure fun times, we just need a little breather here to go. Okay, I know JavaScript, feeling good. So in this case, we have higher order num1, num2. What if I wanted to take this and I wanted to add, and maybe I wanted to subtract? Well, because I'm returning one value, I can't do more than one thing with this function. I can only minus or subtract or multiply. I can't decide which one I want to do. I could use like an if statement and pass in another argument. That would work. Like if an argument in here that had a string matching, like subtract, for example, or the argument I should say is, arg. Well, that's a bad idea, is to have a parameter named as an argument, but compute or something like that. And then we could say, if compute is equal to subtract, which is a string value that we could pass in, well then, return these numbers subtracted. And of course, I could pass in subtract if I wanted to. That's a lot of work. It's a lot of work to do those things. And I could then do, an else statement of if compute is equal to add, then add those things. So you'll see these kinds of patterns start to develop as you program. But that's a lot of if-elsing going on, and pretty soon you could have a huge tree. So one thing that could really help us is if we could abstract these out into functions and then just call the right function when we need to. So how could I abstract these out to functions? Well, I could either use a function expression or a function declaration. They would both be valid. Let's use expressions just because I want to keep us exposed to all the function things. So if I were to write a const here, I would say add, assign the value of an anonymous function, right? Open and close curlies. So we learned yesterday that this syntax is called a function expression. Well, let's say that I wanted to receive, 2 and 4. So I could say num1, num2. So that would be 2 and 4. And I want to do the same thing that this is doing. So I'm going to say return num1, num2. So basically, I've created a standalone function that does one thing and one thing really well. This, by the way, is the kind of the origins of compositional programming. I'm not going to talk about that anymore right now, though. So in this case, I've got my add. Now, if I came in here and I swapped in add, let's see if this thing works, and I'll, of course, get rid of this string I was talking about. Hit clear and run. So you can see the add does work by itself. Cool. So going back to my example where I had the subtract thing in here. Sorry, let's just call it add. Instead of doing all those if-else statements, I could just pass something in here, which I could just pass in the reference to my function. What? That's crazy. Not a lot of languages allow this behavior either. So I can actually reference the function that I want to call later. So I can reference my callback. Now, this is where we start using words like callback, and it's like, wait, what are you calling back to? Well, I'm calling back to add. So I'm saying, okay, add, I want you to run. So what I do to pass in my reference is I say, well, I want add, like that. So there's the one-to-one right there. So now what I can do is call one function and have that one function call back. So I can say return, and what am I going to return here? Out of these three parameters, what would I return to run add? What do you think? That's right, the callback. So I would say callback. What is callback really doing now? Like if I were to translate this, if I was going to translation, really saying this, return add, right? Because I'm referencing add down here. and then I'm passing in 2 and 4. So if I want to translate that, I'm saying like this is pseudocode here. So in our real code, I need num1 and num2, right? Num1, num2. So what I'm really saying is do this. Return add 2 and 4. And so how do you return a function? Well, it works. It's all part of the system in JavaScript. We can do that because we can pass in functions as parameters. So it's as if we're taking this whole chunk of code and dropping it in here. But you'll see why we can swap these things out really quickly. So now that I've got my add thing set up, let me translate it to higher order function, right? Because that's the one we're invoking. So what am I really doing, everybody? Higher order function, higher order function. 2, 2. 4, 4. Add, add. Then this translates to add 2, 4. Okay, let's see how this works. Save and run. And there it is, 6, it worked. So now that I've got this in place, I could now add any amount of functions that do any amount of things and reuse them over and over. So I could come in here and say subtract, for example. I could come over here and say multiply. Come in here and get that. I could come in here and say divide. See how that works? So in this case, I've got all these functions that do one thing. Then I've got one function up here that can do all the things given the right parameters and through the arguments. So let's get them all to work. So you do have to invoke them 4 times, right? So higher order function, there they are. We're calling the same thing every time. But now we're going to say subtract and multiply and divide. Okay. So let's see what we get here. We get all the right answers. So if they're added, subtracted, multiplied, or divided, we get these results. So in this case, the higher order function is the function that can receive other functions in its parameters. That's all it is. That's a higher order function. So anytime you pass a function via an argument that then turns into a parameter, that has now become, by its very nature, a higher order function. So the callback functions in this case are add, subtract, multiply, and divide. They're being consumed by the higher order function. Okay, so conceptually, this is the end of the line. Like this is as hard as it gets for what we're doing today. We will now use the same concept to showcase real life examples for the rest of our time. This seriously is as hard as it gets. Everything else is just using this over and over. So for the next hour, what we'll do is we're going to use array methods to showcase this behavior over and over. But the concept here is higher order functions can receive other functions as parameters. And that's it. So higher order functions, sometimes people call them HOFs, receive other functions as parameters. Callback functions can be passed into higher order functions. So there you go. That's the big difference between the two. Callback functions are passed in, higher order functions receive. Okay? So this is just the concept here that I want you to understand. It's going to make a lot more sense as we continue to work with these things in our array methods. All right, let's take a 5-minute breather, come back, answer a couple questions, and then we'll jump into the examples. All right. Break time is over. I'm going to answer a couple questions. I don't think I'll have time to answer all of them. We'll see. Throwing in way beyond the stuff we're going to be talking about. So I'm not even going to answer it. Let's not. We don't want to goof around with stuff like that. We'll get to more of that stuff next week. So the callback function is holding the value of the program we want to execute. The callback function is holding the arguments of the thing that we passed in. So make sure you're using, like, thinking this is where all that, the value that you were saying, this is, I'm saying, look at this and saying the arguments. So just want to be clear there. Do the parameters in the callback function need to be the same name as the parameters in the add function? No, and I think I answered this. Josh Timmons asked this. But the idea here is the names do not matter as long as you're consistent, right? What matters is the order. So A, B, callback, right? So this will all still work. It's just I want it to be consistent. So you can see here it still works, right? So consistency is a good idea, but that's about it. Okay, this feels like parametric mixins. Is that a good way to look at it? You know what? It's a great way to look at it. Parametric mixins do bridge nicely to callbacks and higher order functions. Could you nest all the callback functions in a higher order function? And will it still work? So if I'm following the rules of what I wrote here, I can only call one at a time, right? Because I can only receive one parameter. So it's 1-to-1. There's no extra stuff here. It's 2, 4, add. 2, 4, add. So I couldn't do 2, 4, add, subtract, multiply, divide. It would break. So I can only reference one function at a time. Again, this is more for teaching. You're not usually writing higher order functions like this. You're going to be writing them like the way I'm about to show you. So hold on. Why do we need to declare num1 and num2 in a callback when those variables are already declared in the original function? Aren't they carried over? So if you look over here, here's where everything really happens, right? This is where the return statement is going to execute the callback. So in this case, our callback, add, is being thrown in here, so add. It then goes to add, so it's as if it's doing this. And then it needs to receive the parameters that came in from our arguments, right? So 2 and 4, so 2 and 4. And then it runs the function. So add gets called or invoked, right, by the nature of this return. And so then this gets popped in, 2 and 4, and then 2 and 4. And then this is returned back to the console, ultimately, by our console log. So if I were to replace all the values with the real numbers, that's how it all looks. So hopefully that helps. Do callbacks and higher order functions have to share parameters in common? They have to share the things in order. So remember, order is the king of using any function ever. So in this case, the order is all that matters. I could go so far as to say callback here, num1, and as long as I was consistent, that's all that matters. Don't get caught up in the names, everybody. It does not matter. That would all work. So pay attention to order. This is the king of all functions forever. Fundamental. What is the difference between a callback and a return? So the callback is the actual function sitting here, like waiting to be called. The return statement is the executor, right? It's executing these things. It's saying, okay, Josh, sir, yes, sir, I will go get the callback you told me to get. These are just standalone functions waiting to be called, whereas the return statement here is the executor. Are all callbacks closures? So in this case, coming back here and you're saying, are we passing those values in? And the reality is, as we return a callback, we're actually calling this in its first state. So we're actually not nesting anything as far as the values come through. Now, if we had a nested function in here, another nested, then we would start seeing a closure. But in this case, we're returning a function. So interesting thought there. How does everything below higher order function communicate with it without being in the same curly brace? Is everything just in a global scope? So in this case, everything that's communicated down, well, I mean, let's go throw a debugger statement in here. Let's see, the problem is we're running our, so debugger. And let's see what happens when add gets called in. So we'll inspect, run it. Excuse me. So in this case, it's going to execute in the order that we had it in, which is add, right? And so you can see here that it just jumps right down. So our debugger statement jumps right down from our return. And so these are passed in, so num1, num2, from right here, right? And so this is not a closure, whereas closures, remember, we don't have anything there. Closures don't have any parameters. In this case, we're passing in explicit parameters, and that's how it happens. So it's just all local scope, no closures here. At least not in this example, because I'm not nesting anything. I'm using parameters to explicitly tell it what to get. So that's how. Would you say higher order functions are like a local library for functions? Yes. It's a great way to think about it, and you can pull off and put in any books you want. Do callbacks need to be anonymous functions, or is that just best practices? Can they be regular functions? They could be regular functions, but best practice would be anonymous, yes. Because it's just extra. You don't need to do that extra thing every time. And let's go jump into array methods and talk about exactly why that's the case. So that's a great segue into array methods. So we're going to call these advanced array methods. So we're going to be talking about using a little subset of data. I'm going to pull this right from basically the training kit. And we've got some city data of 4 cities. It's not accurate. I think we just randomly pull this from an API or something to get this object. So notice what's going on here. We've got an open and closed bracket. What is that syntactically? What is that? That's an array. That's right. And then what are these curly brace things inside of the array? They're objects. More specifically, object literals, right? So in this case, they are objects. And then what are these combinations here? What do we call those? Key value pairs. But yeah, you're right. They are strings. So like those that said strings, you're right. But technically speaking, inside of an object, they are key value pairs. Good. You know all this stuff. Like nothing here is new. It's just been jammed together into one big thing, right? And then we have a const up here. So how is it possible that I could add another piece of data to this? Why is const not yelling at me? Right, I could use push. So how is that possible without const freaking out at me and saying, this is unacceptable? That's right, because it's pointing at the array, right? And so we're not changing the array, we're changing the values in the array, which, by the way, to me is a conundrum, and nothing truly is immutable, but that's just me. So if we come into city data, we now have our 4 objects that are inside of here. And let's say we wanted to loop over these objects and just read what they are. This is a very common thing that you'll need to do in your life as a developer, is to iterate over a list of items. So in this case, I'm going to showcase to you the for each method, which is built into our arrays. So if I go into MDN arrays, array, remember how I told you how to read the documentation for MDN. So you can see over here we've got our properties, right? We learned about .length yesterday. And then we learned about our array methods, which hopefully you played around with yesterday in your project and got more familiar with. And so inside of here, I want to focus more on for each. The for each method executes a provided function once for each array element. I want you to look very closely at the syntax, no tricks. What type of function is for each? Is it a higher order function or is it a callback? Oh man, we're getting a bunch of different responses. So remember, what qualifies a higher order function as a higher order function? What is the one big qualifier? That it accepts a function. So, do you see a function inside of the for each? I do. I see this function. So guess what? By the very definition, for each is a higher order function. The callback function is what in this example? Well, it's the anonymous function, right? It doesn't have a name. So I'm not trying to be tricky. Good job, Roman. But it is the anonymous function. Good job, Brandon. Excellent. I don't fault you for saying element, by the way, because it makes sense. It's like, oh, element. But in reality, it just doesn't have a name. It is nameless or anonymous. Okay, good job. So guess what? We're going to be using exclusively the concepts here covered up here with higher order functions and callbacks now for the rest of your days as a developer. Like they're part of everything you do. So the for each is going to go through now. Before we get into a for each, well, let's just get into city data for a second. So city data, of course, is our big array, right? Like we know what that is now. So how we use array methods is we use the syntax here. So array is just like our city data. And then remember what I told you, when you're learning something new, just copy and paste. No need to be a memorization hero. So just look at this and go, okay, how do I use this thing? Well, only thing I'm lacking is city data, right? So you pop it on here and away we go. So let's see what we get here. Save and run. And we get all of our objects. This is great. This is exactly the behavior that I thought we would get here. So there's something interesting going on here. We have a function. So if I were to abstract this out, you can clearly see for each is just a method, right? What is a method? When I say method, you think what? A function and an object. Very good. Yep, very good stuff. So you can tell it's a function because of why? The dot syntax, right? And of course, if we were using bracket syntax. But in this case, this is what you're mostly going to see in the wild, is an array that then has access to these methods. So by the very nature of it being an array, we gain all these properties and methods. And we're going to learn how that works tomorrow, like why that actually happens through inheritance and prototypes. But for today, we're just going to focus on that we can use for each. All right, so then for each has an anonymous function inside of it, right? Now, yes, could we do this, by the way? Could we abstract this function out, give it a name, named function? And could I reference it here? Would this work? What do you think? Let's clear it, save it, and run it. It does work. So do you see how this is kind of unnecessary, though? Like, we don't really need to do this abstraction. It doesn't help anything, except maybe for teaching. Like, just to show you that the for each receives a parameter. So truly, this is a callback, right? Truly, this is a higher order function for each. But in order to avoid unnecessary abstraction, we can simply use our anonymous function inside of here. So I just want to show you the before and after there. Pretty cool. There we go. Now, those of you that are my arrow function junkies, let's convert this into an arrow function. Arrow for each. So in this case, remember, all we've got to do is eliminate the function keyword, throw in the new symbol. That is the simplest transition from a function expression into an arrow function. I did promise you that we'd go a little bit deeper today. So arrow functions allow you specific rules. I provided you a Medium article and talked about them in Training Kit, and even in the video I talked about them a little bit. But I'm going to show you a couple cool things here. If you only have one parameter, you don't need the parentheses anymore. They are optional. Isn't that crazy to have something optional that felt like it was totally necessary? So you don't need those anymore because it's implied or implicit or automatic. Guess what? We also don't need the curly braces if we are only returning one value. So in this case, console log element is all we need. Wow, that's way more clean, but also way abstracted. Like, you have to know so many rules as to why that works. So if we come over here, comment this out, let's see if it still works. Still works. So the problem with this is the abstractions if you don't know why. And that's why I don't like arrow functions for new developers and even old developers alike. Sometimes the syntax is so succinct that you miss out on a lot of the structure. So I wanted to show it to you for all my arrow fans, but in here, let's stick with this and keep it robust so that we can read the syntax and learn. Okay, so for each, that's pretty cool. We can go through every item and do something. So what's interesting and something we haven't talked about is the actual syntax. There's more to this than meets the eye. It's like a transformer over here. So we've got our array, which was city data. We've got for each, which is our higher order function. And then we've got our callback function, which we've been using, right? Our anonymous function. We then received current value. Without looking back, what was current value called? Do you remember? It was element. Yep, that's right, element. So it just shows you that even MDN is not following a naming convention, right? Like, they're calling their stuff element, even though in the syntax they even identified it as current value. It just goes to show, again, that names don't matter, position does. So in this case, the current value is element. Then look at this weird, crazy stuff. This is some crazy looking syntax. This is basically saying you can grab the index. What is the index? Do you remember what that word means when it comes to arrays? It's the position. Very good, very good. And guess what? You can even return the whole array if you need to and use it inside of your curly braces. I very rarely, if ever, use the full array, but it's available for you. Let's go into this. So current value was, let's just call it what it is in the syntax there. So let's just hit save and run. Current value kind of makes sense to me, actually, more than anything, because it's the current value of each item. Let's see what the next thing is. Index. So I'm going to come over here, console log, index. Let's see the difference between the two. Save and run. So you can see we get the object, then we get the index of the object. Object, index of the object, and where it pertains to the array, right? So 0, 1, 2, 3, 0, 1, 2, 3. So that's kind of interesting. And last and certainly not least is the array value. So if we hit save and run, you get the individual object, the indice, and then you get the whole freaking array. So you can see why I don't use that very often. Like, I haven't found a lot of good use cases, unless you're maybe trying to compare them, but I would use a different method instead. But that's pretty crazy. These are implicit. That means they're automatically passed in. So if you don't know that and you try to pass in something here, it's going to think it's the index. The good news is, usually with most array methods, you're only wanting the current value, and then you do something with it. But this is kind of interesting to see. These are definitely optional. So if you come up here, you can see in the parameters, the callback function is needed. The current value is why we're even here. And then the index and the array and the this argument, which we're skipping over again, these are all optional. They are not needed for the for each to work. You only need the callback function and you only need the current value. So in our case, the callback function is our anonymous function, check, and current value, check. So we don't need index and array. But I would be remiss if I didn't show you those portions just so you can understand how they work. So save and run, and you can quickly see, there we go, there's our objects. So what can we do with this? Well, we can use dot syntax and any other thing we want to use. Like we can now do whatever the heck we want. So if I say current value, and how can I dot syntax into city? Well, I just type city, right? And let's see what happens here. Save and run. And now we can see, we got all the cities. And this would go for anything, right? State, population. That's the beauty of the fundamentals you've been learning. Like all the stuff we learned yesterday applies everywhere. So in this case, current value, state, state. And then we get all the acronyms, right? So for each is really powerful. It does have a weakness though. For each must iterate through every item in the array without stopping. So for each can actually be worse in performance compared to the native for loop, like just the basic for loop in JavaScript. So in that way, for each is not great for performance on bigger chunks of data. If you need it to gain some performance back, you can actually use a for loop and it's actually faster. That's when you start splitting hairs on bigger subsets of data. For most everything in your life, for each is going to do the job. So what's returned from for each? Like, well, it's whatever we tell it to. So we can come back in here and return something if we wanted to. But the return keyword is not needed in for each. It's implicitly going to return something, but we don't need to actually say return. Versus for our next method, so we're going to jump down to map, it is required. So for each, by the way, is used for going through, looking at data, finding certain pieces that we need to do. You can manipulate it, you can return, you can push to a new array, you can do anything you can imagine inside of these curly braces. So for each is pretty much used for almost everything and can be a hammer for every job. However, sometimes we need to be more succinct and we want to do a specific thing. So I look at for each as like the basic iterator going through everything. But let's go a little bit more into detail. So map, let's go look at map up here. So remember, I'm going right off MDN. The map method creates a new array. So that's different already. For each does not create a new array, like that's not part of its makeup. So that's something new right there. It creates a new array with the results of a calling provided function on every element. So that means that it needs to have that return in here for this thing to work. Now they're using an arrow function, which I wish they didn't, because they're showing you the most succinct syntax and it looks so pretty, but it's abstracted the return keyword away, which I don't appreciate. So in this case, we've got our map and we're converting it and doing something. So in their example, they're saying, take these numbers and return a new array of those numbers multiplied by 2. This happens quite a bit in jobs where you've got a subset of data and they want you to convert something in that data and then return a new version of that data without wrecking the original array. It takes a lot of time to get data. Like getting data is so valuable, especially in this day and age. So we don't want to mess with the original data. We don't want to manipulate the original data. We want to give a new version based off the original. So let's say that this array was, hard-fought data from thousands of hours of gathering, survey information. We would never want to go through this and wreck that original data. We want to keep it in its original form. So we can use map to create a new array and do something to it without messing with the original. So hopefully you're seeing the value of map just in that one way. So let's go see how this works. We've got map, we've got our city data. Let's say we wanted to do something to our city data. And in this case, let's talk about converting. So map, I think, is used a lot for converting. At least that's how I've been using it, and a lot of other developers use it. So let's say const, and we're going to make a new map. We'll say new city data, because remember, it's a new array. And in this case, let's make it lowercase. So we'll say city lowercase. That'll be our new array. Now, normally when we set up a new array, we have to initialize it, meaning we have to set it to be an array. The crazy thing is we don't have to do that, because by using this assignment operator, we can actually go right into city data. So there's our array.map, like that. Because remember, map returns a new array, creates a new array, I should say. So in this case, map then needs to receive an anonymous function again, right? So here's our function, open and closed, curlies. And so in this case, the return keyword is required. And if we don't have a return keyword, it will freak out at us. So map needs that return keyword, which is different than our good friend for each, which doesn't require the return. So in this case, we're returning something back to city lowercase. So right now, city lowercase is an empty array. It's as if it doesn't exist. If I were to do this like in an ES5 way, I would set up const city lowercase. I don't know why I'm trying to retype something I already have. I'd be setting it up to an array, and then I'd be running a native for each loop, like for. Then I'd be doing something in here, and I'd be pushing to that new array, okay? But inside of map, it's all assumed, it's all automatic. So city data, I'm mapping over this. So when you think of map, I want you to think of maybe convert is a better word, but they used map for some reason, maybe because it's so short. But in this case, we're going to be converting something and returning something new. So returning something new means we've got to have something old to go over. So let's say we have the current value, right? So just like we had current value up here, we have the same thing down here in our syntax. There it is. That's why we spent so much time on for each, because now you can quickly see current value, index, array. It's the same thing. The only thing different is that we now have to return the element. So in this case, callback is required, current value is required, and of course these three are still optional. But the thing that's new here is a new array will be returned. So that's the big difference between map and for each. If I wanted to put these in notes for you, which I probably should, it's all in training kit, but I think it's always good to have these extra things. So returns a new array, doesn't manipulate the original array. Whereas with for each, and do anything you want inside the callback. And so in that case, it's way more open. You can, and let's say must iterate over every item in the array. This applies to all of these, by the way. In this case, for each is going to overrate, and so does map. So I don't know if I want to put it, just assume it's going to be on all of them. So, all right, so returns a new array, doesn't manipulate the original array. So in this case, we're going to return something new, and in this case, current value. So remember when we went over here and we got these, let's convert these to lowercase since they're all uppercase. So remember up here, it's current value.state. So we're going to say current value.state. And we'll use the string method to lowercase. I want to show you something I just did that maybe I take for granted, is I'm taking to lowercase. I don't just have this stuff memorized, by the way. Like I've used to lowercase a lot for different things, and so that's why it just came into my head. This part came with just years of playing around with things. So don't think that I have all these methods memorized. There's no way. But sometimes that feels like magic. Like, why does he just know? Don't worry about that. That just, something came to my mind. Used it in the past. So in this case, I know because I just ran up here, I'm going to get these capitalized WA and Y, right? I'm going to return a new version that's lowercase. So let's see how that looks. Console.log. We're going to log our newly returned array and see what that looks like. Okay, here we go. Save and run. So you can see when our for each up here, the before was WA, NY, MA, and then below we now get a new array with everything lowercase. So in this case, you can now see the difference between for each, which is just basically giving us data, right? And then inside of map, we're actually doing something and returning something back. Okay? So map is basically the great converter. Like, always think about conversion. Think about converting when using map. So if you ever need to convert something, map is the best thing to do it. Amanda says, I see the value of using map as a function expression now. You got to store that new array. Exactly. Very well put. So in this case, we're using this as a function expression really to now pop in that new array. So great mapping there. Ha, pun intended. So that's what map does. It's a converter. It takes something, makes something new without destroying the old. It's extremely valuable. Think about Fahrenheit to Celsius, lowercase to uppercase. There's so many things that you will be asked to do by an application. It's like while you're building an app, the client will say, I need this feature. And if they ever talk about converting something, or if even the back-end developer is like, well, I can't do anything with this data, I need you to convert it. Then you can go, cool, I know how to do that. I'll use map. So map is the first tool I grab when conversion of something from something else needs to occur. Whereas for each is the first tool I grab if I need to iterate over a lot of data and figure out something or do some calculations on it. Okay, so that's map. I'm going to go ahead and just console log it, or comment out the console logs. Okay, the next thing is filter. So filter also returns a new array, does not manipulate the original array. And then I want you to think about, well, filtering out results in a new array. So where map is all about converting, filter is all about filtering. Sounds silly to use the word, but it's very, like, I like this. I like filter because you read it and you instantly get it. Whereas map, you have to kind of wrap your mind around. You're like, wait, map? Like, is it a map like a cartography or what is it? And in this case, filter is just like, nope, it filters, and it does a really good job of it. So I'm going to go ahead and just comment this out so we can bring it along with us. So I don't have to keep scrolling up and down. So with filter, I'm basically going to borrow the same syntax from map. So you're going to see a lot of similarities. So we're going to say, I'll just call this like new city filter, just so we can have a new array name. And then we'll come over here and change map to filter. But I want to show you that current value never changes. That's one of the coolest things about these array methods. So if we come back over here, we go to filter. The filter method creates a new array, so there's that new array thing, with all elements that pass the test. So basically, we write a little test inside of our words here. So inside of our, man, they always use arrow functions. I wish they didn't. But you can see we've got the callback, and then we've got the insides. So in this case, again, we have an index array. But here's the thing. Here's the big difference. Is function is a predicate. To test each element of the array, it returns true to keep the element, false otherwise, then it accepts 3 arguments. So I'll keep that. Let's rephrase that. So if true, keep the element in the new array. If false, don't keep it. So in this case, new city filter is going to be filled up. So if I took the console log here, with all of the truth and not the false. Okay. So in this case, we have to write a statement that can either be returned as true or false. That's the only gotcha. So true or false. I think that's a great way to start thinking about filters. Just say this out loud to yourself. Say true or false, and then write the statement. If it's true, it goes into the city filter. If it's false, it doesn't. If you don't think that way, it can be a little confusing at first. So let's say we take the current value, remember, which is just each one of our objects. So 1, 2, 3, 4. Hopefully we're feeling really good about that now. And let's take something like population, because we got ourselves a nice number that we can true or false against. So then it's like true or false. This city, the population of my object is going to be less than 650,000. 1, 2, 3. True or false? If the answer is true, it gets thrown into the city filter. If the answer is false, it's ignored. So based on my assessment, what are the ones that are going to come in here? By the way, I appreciate all of you and your sarcastic comments that I agree with you. Semantic JS OMG. Thank you. In this case, okay, so you're saying Boston and KC, true or false? Okay, let's find out if you're right. Save and run. Let's see, do I got an error somewhere? Current value, return current value, population. Let's see if I spelled that right. You never know. Less than 650,000. Okay, city data, yep. Filter, yep. Oh yeah, these things are probably freaking out. Let me comment out anything here. Okay, let's see, save and run. There we go. And there it is, Boston and Kansas City. Good job, everybody. But isn't that cool? Like, true or false? That's just a great way to think about it. I have a 8-year-old son that loves to say incorrect whenever I say something. And so in this case, you can say if it's incorrect, it goes outside. If it's correct, it goes inside. And it's that simple. If you didn't have that mentality, this can be a little weird at first. It's like, wait, return current value population less than 650,000? But if you pop a question before it of true or false, the current population is less than, it makes a lot more sense. So this is exactly what filter does. It's beautiful. Filter is extremely valuable for getting answers that you need from subsets of data. So there you go. That's filter. Okay, the last one is more of a Swiss Army knife, whereas all of these are like forks and spoons and stuff. This last one can do all of the above if written in a certain way. And because of that, it definitely causes a lot of confusion for new developers and old developers alike. Yes, it's not called spork, but I wish it was. It's called reduce. So reduce returns a value. And so in this case, we can return a value, and that value can be, it's not an array. So as with filter and with map, it's returning an array. But reduce is allowing us value. So a lot of times reduce is used for summations or multiplications, products, and I'll show you what that means. But you could literally use it for anything. Let's see. It doesn't manipulate the original array. That's true. Returns a value, not an array per se. By the way, you could push into a new array. That'd be value. But as far as the default, reduce does not return an array. Let's see. It returns a value, not an array. Good. Returns doesn't manipulate the original array, which is also very good. Usually used for sums and products, meaning multiplication and addition, or addition and multiplication, but could be literally used for anything. And that's where it can get a lot of people confused. So I want you to just focus on the simplistic uses today, and then we'll go crazy later on in your career. So in here, let's go look at the reduce. So the syntax is array, reduce, callback, and then there's some initial values. I don't know why they have that. I don't know why they have it that simple when it's not. So in this case, the syntax is actually requires an accumulator, which is new. So this needs an accumulator, accumulates the callback's return values. Basically, this is a running total. So when you think of the word accumulator, I want you to think of something that's being added to, right? It does make sense, accumulates things, but sometimes having synonyms helps. And in this case, I would say running total is a good case for that. Current value, we already know what that is. And then index, we know what that is, right? But then there's something else in here called the initial value. This is the value in which it starts the summation or the product or whatever. This is where do you start from. So if we come over here, and we grab it, sorry, go back up to the example. The problem is, the example again is they just love using arrow functions here. And I get it. It looks so clean and easy, but I don't like it. So we're going to go back. We're going to borrow from filter just to grab some syntax here. Now here's where it gets different. It returns a value, not an array. So just keep that in your mind. And in this case, we're going to set up a value and we're going to say total land area. We're going to get all the land area so we can use all the different portions of our data set for today. And then we'll be done. So total area, we want to find out what's 83 plus 302 plus 48 plus 315 plus the dots. So in this case, reduce is a great candidate for this. So we're going to use reduce right there. We've got the function that stays the same, current value. So this is where things get different. I don't like how their documentation kind of bothers me. But the accumulator actually comes first in order. So if we need to start accumulating, well, then we need to accumulator right there. And then the current value is passed in. So this is where reduce is different than all of its other siblings that we've talked about with array methods. It's got an accumulator or a running total. Then one of the last things that it talked about was this weird syntactical piece down here of where should it start. And it's optional, but we're going to put it in. It should start at 0 because I don't want to start at 100. I want to start at 0. So in here, we're going to return the accumulator plus the current value of the land area. Because we've got to grab the thing, right? Get rid of this weird thing there. So land area, we want to get these numbers. So I think something that's helped me is to console log these so we can see them one by one. So I'd come in here and I'll say, I am the accumulator. This always helps me as a new developer just to kind of talk to myself. And so I'd say accumulator, right? Because it's coming in from our parameter. Copy and paste. I am the current value. Just so we can see exactly what's happening on every iteration. It does help. Okay. Make sure there's no other errors up here. Okay, good. No other references to the data. So I'm going to hit run. And what I want to do is what's going to happen is it's going to start adding up my values. So current value, again, is each individual item, right? So the first thing it's going to find is 83.9. But it's going to start at 0 because that's where I want to start. So let's see what it looks like. Save and run. All right. So in this case, I'm coming in here and I'm saying, let's see, did I spell that right? Accumulator, current value, accumulator, current value. Oh, I don't have a D in there. There we go. Spelling is going to kill all of us. So in this case, there we go. So I am the accumulator, 0. So there's my 0, right? And current value really should be dot land area. right? Because that's what I'm trying to get. So let me get rid of the object for us. There we go. So in this case, I'm the accumulator and I started at 0. Why? Because that's where all accumulators start with the number we tell them to. I can make this 100 and watch the difference. Save and run, and you will see that it starts at 100 and then adds on to that. Why would you ever change it? Well, in this case, in this example, I don't know. We wouldn't need to. But in other examples, you could think of reasons why. Because it's a Swiss Army knife, can be used in so many ways. So in this case, I'm the accumulator, 0. So that's our first value. I am the current value, 83.9. Makes sense? 0 and 83.9. Makes sense. Okay, then it iterates again. I'm the accumulator, 83.9, because that's where it came from, right? The running total. Then it says I am the current value. Well, the current value is 83.9. Or sorry, 302 that's coming through. And then they get added together, right? Right here. So then the new value is 386, et cetera, et cetera. It just goes through and adds each item until we get the end result where it stops. So if we wanted the end result, we'd have to console log the total area. Clear, save, and run. And then our last item should give us the total land mass, total land area, I should say. This shows you the insides of what's going on with the running total, the accumulator, and the current value being added together. And that's it. That is reduce. So here's the thing. Here's the big grain of salt. In your life as a developer, you will be using filter quite a bit. You will be using map quite a bit. You will be using for each quite a bit. You will be using reduce not very much. So if this last portion here kicked your butt, don't worry, chew on it, look at it later after lunch, look at the accumulator, see how it's adding things together, and start trying to play with it. And you have like one project problem with reduce. So I'm not putting a ton of weight on reduce is what I'm telling you. But when it comes to filter and it comes to map and for each, totally invest time in those because you're going to be using them a lot. Okay, not discounting reduce. I'm just giving you an example of usage in the real world. Now, okay? So don't let this blow our minds too much. It's fun, it's good stuff, but it's not the end all compared to for eaches. Okay, let me hit save. Let me give you our final CodePen link. By the way, the starter file would have been a blank CodePen, so no need there. And that is it, my friends. So if you look at the project this afternoon, it's a conglomeration of all these ideas together in the assignments folder. So closures, callbacks, and array methods. With array methods, I just give you a giant piece of data again, and then you've got to use for each map, filter, and reduce to go over that. And then this might be the hardest and or fun part of the day is you've got to come up with problems and solve those problems using these array methods. So this is actually really fun because everything up until this point I've been telling you what to do. And now for these, you tell me what you would do to solve the problem. And it's always fun to see the brain get to work on this. So you've got to think of problems to solve with this data set. So that's it. That is your assignment for today. If you're feeling good about everything, you're free to go. I will answer any questions that are lingering in here. What object holds for each push, etc. So it's just an array, if that's what you're talking about. So everything is held inside of an array, to be very clear. How do you know when to use map versus filter versus reduce first for each? So it depends on what you want to do. So if you want to convert, use map. If you want to filter something out, filter. If you want to add something or multiply something over a big piece of content, reduce. There's more to that, by the way, but I think that's a great way to start thinking about reduce. And then for each is if you want to go through a ton of data and get something, like if you need to get some piece of data out of a big subset of data. So conversion, filtering, adding and subtracting, or sorry, anything you want to do with a running total. And for each is like if you're just curious about a piece of data and you need to do something with it. And that doesn't mean you're converting it, doesn't mean you're filtering it. So you basically have so many options, it's overwhelming. But I would start putting these things in easier boxes, like filter map, I know what to do with those. For each, you'll just start to find naturally you're using it a lot. Reduce is like, you have to find ways to use it, but usually summations, products, great way to start. How does it take the string value and notice it as a key? How does it take the string value and notice it as a key? String value. Guess I'm not, you're talking about the object here. So because of object literals and how they're made, remember, I mean, we did this yesterday, but we wrote them like this for like human readability, right? But notice those commas. That's how they know that they're string value pairs, because they're inside of these blocks of curly braces, right? So if I were to make it look like yesterday, you would see they're almost anonymous objects. They are truly anonymous. They don't have names. But how does it know? The indice, right? So in this case, this is the 0th position object, and it knows what to do with it. So I think that's a great question. Like SAS to CSS, is there a place where we can plug in abstract to JS code and have it fleshed out for us? Yeah, so Babel will do that in this exact tool right here. So this is a full tool that you can apply to your code stack. But if you're seeing next-gen JavaScript, for example, let's say we had a function that was an arrow key, a function expression. So const, expression example. Oops, sorry. And then we assign it to be a function like this, console.return. We'll just say, testing. So in this case, notice that it's one-to-one. It's taking our function expression and even assigning a name to it. Kind of fascinating, right? If we removed the function and turn it into an arrow function, you can see it keeps it as the original function expression. Pretty cool. By the way, you can install this stuff in VS Code and see these things differently, but this is a great tool for you to start seeing these abstractions and see the original. So for example, I could take this return out, I could take this out, and you can see that this still translates back to the original. So there you go. Kind of a cool thing to see. I'm noticing most of the arrays we're seeing are arrays of objects rather than arrays of primitives. Is this how arrays are generally used in the field? Well, usually JSON objects, so JavaScript object notation, are kind of the common theme you're going to see in APIs when you get returned values. So yeah, honestly, it's very close to what you'll see in a lot of the workplaces is this stuff right here, this kind of notation. But that doesn't mean it'll always be the case, but in general, I would say that's a good place to start. Is there a good master list of built-in elements like 2 lowercase for reference? Yep, MDN, I'm not kidding. So I'm not being a jerk, it's just MDN has all this stuff in it. So if you wanted to look up strings or anything, they would all be in this list of here, right? So like if you typed in MDN string and you looked up string, you would then see all the stuff that we're talking about here. And there's 2 lowercase. So MDN is really the best place. Can you give an example of an IFI statement? Let's not do that today. Our brains are properly exploded. By the way, I do show an IFI statement in the functions video for JavaScript Day 1 if you want to go look at it. Touching on this in the training kit, I made const total animal weight, reduced accumulator animal size. Okay, animal accumulator plus animal size weight. Overkill? No, that looks great. That looks great. Can we do more with reduce this week? Maybe Q&A Friday. Sure, yeah, we can talk about it more. But go play with it before you got to go mess around with it and break it a little bit. If it's automatic, and by the way, console log the crap out of everything. So if you're not doing that, you should be. Console log everything. Is it automatically passed in? Do we need to include index and array and all that example? So remember, when you're using these array methods, I'm assuming, I don't know the context here of it is, but yes, every array method that we're using has those implicit pieces here that we were looking at. So array, oops, dn array. So this right here, at least with the ones I showed you today, with like map reduce for each, they do have the implicit nature here. And so if you're not aware of that and you try to bring in something else, it won't work. So yes, be careful of the implicit order. How come we didn't have to write out a for loop? That is because it's happening automatically with the array methods. So if we wanted to write out a for loop, we could. It would be more appropriate for the for each area. In this case, by the way, if you want, I think in the last time I taught this, I spent more time with native for loops. So if you want that kind of detail, I actually recommend watching the Web 18, and I do actually show for loops. So if you're really interested, go check that out. Can you do filtered array, assign the value of an array, filtered array push, new city filter? Yes, you could totally do that. Like if you're talking about reduce or something, yes. Would you ever write out a full conditional statement for a filter? No, because the filter it's automatic. So that's a great question. But the answer to that is no. Can we review reduce one more time? Sure. If you're here, we'll just keep going. So in this case, reduce is taking the chunk of data, right? City data. It's running through it. The accumulator is the running total. Oftentimes, I'll change it to say that just to help my brain. So I'll do something like that. Just makes more sense to me, I think, than accumulator. But if you think about it, they are synonyms, like with the same thing. So current value, we should know, is each item that's getting passed in. The current value dot land area is going to be each one of these, right? 302, 48, 315, 83.9. So in this case, I'm going to be logging out the total land area. So total land area, every time it gets console logged, well, it's only getting logged one time because it has to iterate through each item and then it gives us back. That's why we don't see, 4 numbers and then this number. It's accumulating all these things first, and then once it's done with our array, then it returns the value. Very convenient, right? Like the fact that we didn't have to see 4 different values here, we just got one final value, is really the big, awesome time savers that did all this for us. So 749.8 is the result of 83.9, 302, 6, 48.3, 315, as they have been reduced down into that final number. So I say that sentence because that's proper, but in this case, we're adding them together. So we're taking the running total. So if you look over here, the running total starts at 0, right? So under this, guys, if we tried to use multiplication, do you think this would work? What do you think about that? If my starting number was 0 and I'm using multiplication. Those of you that are still here, what do you think? Could I run that? No. Ooh, Amanda says yes, but it'll be 0. I like your thought process. And Melissa also. Okay, so let's hit run and see what happens. 0. Why? Because anything divided by 0 is 0. So We could change the initial value to 1. Let's see what that does. Save and run. And what is 1 multiplied? Well, it's the same number, right? So that's a great number to start with, because then we can actually get the value. So if we divide by 0, the universe collapses. But if we multiply by 1, we're fine. So there are some math things that we have to keep in mind when we're using different operators. Otherwise, we'll be in a lot of problem. Like, that's why the accumulator does matter, or the initial value does matter. So in that case, hopefully that was a good example, non-example of like why this number matters. So then our running total starts at 0, right? Our current value starts at 0. And then the first value is 83.9, right? 83.9. So that's like our first return. And then it just loops every time. And so then it says, okay, the accumulator is 83.9. And now what's the new number on the right? Well, it's going to be 3026, right? 3026. Then what does it do? It actually adds those numbers together. So then we get 3026. Doing math live is the worst thing. So I'll just make up a number, 900, whatever. Then over here, we get the new number, which is 48.3, right? See how it works? It's just a replacement and add game. It does it over and over and over for us, n amount of times. So we don't have to think about it, because computers do math better than humans. So if we save and run, you can see all the stuff I was doing. 0, 83.9. Then it moves over to the left, 83.9. To the right, 302. Moves to the left with the new number. You see what it's doing? Then the final number is 74.9.8. So there you go. That's reduced, re-explained. Again, don't freak out about this. It's something that can be used at the right spot in code, but it's used a lot less than the other array methods. Okay, thanks everybody. I'll get make sure Nathan gets this recording up. Sorry, Nate, went over a little bit of time here, but I think it's helpful for those that stayed. It's a big day. Tomorrow we'll be going into prototypal inheritance, and it's going to be awesome. Tomorrow is going to make your head spin more than today, but it's going to be like, whoa, I actually understand JavaScript's like core tenets. It's going to be pretty cool. All right, see you tomorrow. Remember, take that full hour lunch break, even though we went over a little bit today, if you're still in here. Talk to you later.